Welcome back, chemistry fans. Today, what we are going to do is a warm-up for the previous topic where we talk about the solubility off of the graph. We talk about the solubility rules. All right, let's jump into this. Let me share my screen with you, and I will show you tonight's homework, unfortunately. So let me jump to this, which is what the actual questions are. Now, I understand this is a little bit small, so let me blow this up so that you can actually see it, and then we'll move from here. Okay, so on this curve that you are having reference to for questions 1, 2, 3, and 4, wanting you to tell me which of the materials on this curve is a gas. Well, this goes back to the discussions that we had in class that says that all of the solubilities are temperature dependent, that generally speaking, we will only have very few materials that are solid that don't increase over time. So if we're looking at this, notice salt, it does not change very much. And in fact, then there are a few. This one here is actually decreasing. But this NH3, this is one in which it is a gas, and it is going to be then the one that decreases with an increase in temperature. So how do we know that one? That's only by familiarity. That you would not have, I would have forgiven you had you thought that this one also is a gas, but it is in fact a solid. The gases are the ones that typically move down in this case, but it does highlight the point that not all solids will increase with an increase in temperature. All right, how much NH4Cl will dissolve at 65 degrees? So first we got to go onto the graph and find the NH4Cl, then we got to find 65 degrees. So let me erase all of the circles that I've done so far. Let me highlight the NH4Cl. Let me find 65 degrees, head up to our line, go across, and it looks like you're somewhere in the neighborhood of about 57 grams is what will dissolve. Okay, how about then, if the temperature decreases to 15 degrees, how much is going to precipitate? Okay, so we're still on the same material, same line, but now we're at 15 degrees. So this line has decreased, and so its solubility decreased, and now the maximum that can fit in here is somewhere right around 35 grams. So the difference between these two values is going to be 22 grams. This is how much it will precipitate. So it's where it was compared to where it is. That difference is how much would precipitate out if you reduce the temperature. All right, will the new solution be unsaturated, saturated, or supersaturated? Well, if you have too much in the solution, it's going to be supersaturated. All right, so moving on then. Here's one more question. We've got rubidium phosphate. Let's go find the phosphates on the rules chart here. Phosphates are at the very bottom, so I'm going to actually not be able to see it. Let me see if I can get this thing. There it goes. And it says that all group 1A elements. Well, rubidium happens to fall right there on group 1A. So these are your groups, and there is rubidium right there on the left side of this chart of the periodic table. So that means it is one of the group 1 elements. That means that normally phosphates are insoluble, but because of the exception, it ends up being soluble. Okay, thank you very much for your time. Hopefully this is a nice review. You do have an exam tomorrow, so make sure that you understand this stuff. I'll talk with you again soon. Farewell. Bye-bye.